So we're going to move on to subprograms now, and you've noticed that I've decided to go to a new file. The other one's getting pretty crowded, and this one needs to be clean to make sure that we can emphasize the point of a few key details. So the first thing we need to realize and discuss is something called scope. Now, if you recall, when we decided to create our variables, we were doing all the work inside of the main, public static void main, and this is where the code starts in every C# program. So everything's going to happen in here. So if I want to create a variable, I would just say something like string name, and I don't know, call him Patty. Call her Patty. There we go. So Patty's here, and we're going to display Patty's name. Console.writeLine name, and we're going to put in Patty. Almost put the word Patty. That's not what I want. Name. There we go. And that's fine. We run the program, everything should work. It always takes a little bit of time. There we go, name Patty, that's great. Now there's a second place we can create our variables if you recall. We can also create our variables. I'm just gonna grab this up top here. Oops, not what I wanted. Up top here. So we have string name Patty. Now if I run this, we're getting an error. And the reason why we're getting an error is because, as it says, an object reference is required to access a non-static member main class.name. So it's saying name is not static. Yes, that's true, it's not static, but why does it need to be static? It needs to be static because main is static. Think of static as just like a label for now. Basically says anything in here has to have this label. And anything, and because the name itself, the signature line itself, has the keyword static in it, that implies that anything created inside of here is also static. But name wasn't created inside of here. It was created outside of that area. So in order to use this variable inside of here, it has to have the same label. So we have to define this variable. So I have to use my mouse pad instead of my mouse. Sorry, my touchpad. So in order to make this happen, we have to define this as static as well. So static string name Patty. The only exception to this rule are constants. If you understand the definition of the word static, just in general, the word static means constant. It's unchanging, right? Oh my goodness. It means unchanging. There we go. Why is that not giving me my space? So if I wanted to create a variable, normally I would just say something like const double pi equals 3.14, and that would be fine. And it is fine up there. But why doesn't it need static? Because it is not, because the constant itself already defines it to be static by its nature. So if I want to display it down here, even though I don't have that keyword static, I can still say console.writeLine. We'll just put pi in here for a second. Oops, pi. And then if we run our program, we get it, 3.14, name Patty. So it actually works. So constants are the exception to the rule. It's the one thing that you can create outside of main that does not have to be defined as static. Now, that being said, what do we call these variables? So these variables up here that are created outside of main, up top, are called global variables. And they're called global variables because they're accessible globally throughout the whole program. Any variable created inside of a code block, such as main or what we're about to talk about in a second, is called a local variable. And it can only be used inside of that area. So I'm going to create an integer, and we're going to show you this in a second. I'm going to say int user age, I'll just say age this time, is equal to 17. Now I didn't have to use static because I'm defining it inside of a static code block. So it's okay, it's already static. It gets it for free. Great. So now let's get into the whole point of today's discussion. The discussion here is something called subprograms. And a subprogram, if you recall, is just a mini program inside of our larger program. And there are two types of subprograms. There are procedures and functions. Now, you're going to hear a lot of different terminology for all this stuff. So depending what language you're working in, some languages just call all of these things functions. Some languages call them methods. Java uses methods, for example. Method basically is the same idea. It's a subprogram, a mini program within the program. Now, the reason why I use the technical term, which is subprogram, is because this is education, so I'm trying to make sure that everything is clear. Now, the first part of this is, as I said, there's two types of subprograms. There's a procedure and a function. There is a difference. Procedures perform a single task. That's it. They just do work. Whereas a function does work and it returns a result. So what that means is that it does everything a procedure does, plus it gives us data back. And we've already seen a few of these. Console.WriteLine. This is a procedure. It just does work. It just displays something on the screen. WriteLine is the procedure. The opposite of WriteLine is readLine. That's a function. It does work, but it also gives us data back. It gives us whatever the user writes on the screen. So those are the difference. Those are the examples of procedure and function. Now we can create our very own, and they kind of work like a stamp. You only have to create it once, and then you can use it over and over and over and over again. Just like WriteLine, you can see even on the screen right now, I have more than one WriteLine. It is kind of like a generic template of a set of actions. So we're going to group up a set of actions to do a specific task, and then we can tell it to do that task whenever we want it to. So such as WriteLine. I want it to write line whatever we tell it to write. So how do we do this? Well, let's start off with the easiest part, which is a procedure, which just does a task. So we're going to say, okay, the way we define these is, for now, we're going to say that they are, am I going to go into this already? Yeah, no, we're going to keep it. So we're going to say public. And now, since it's a procedure, it doesn't give any information back. We're going to say public void. What void means is nothing, null, zip, zilch, nada. It means nothing comes back. Normally, we may put a data type there if we're going to return a value, but we're not returning a value. We're returning nothing, so it's void. So public void, and now I have to give my procedure a name. Now that name needs to be descriptive of its purpose. That is the most important part. It's descriptive of its purpose. And the second thing we have to do is we have to follow mixed case. Mixed case means start every word with a capital letter. That's it. Just start every word with a capital letter. So this one, I'm going to have it display the user's information. So let's say display user info. That's descriptive, and it uses mixed case. The next thing we need is brackets. Now brackets, what we put anything that we need, we define new variables inside those brackets called parameters, or temporary variables that only exist inside of that subprogram. They're temporary, they're local. As soon as that subprogram is done executing, they get deleted, they get thrown away. So say, for example, what user info do I want to display? Maybe I want to display the user's name. So let's say string username. And maybe I want to display the user's age, int user age. Great. So just drop this down for a second. What I've created here, this is the signature line. It's called signature line because it's unique. You can only have one of these in the entire program. I could have multiple subprograms in my program named display user info, but they are going to have to differ in other ways, such as the return type or the parameters they need. Now, let's do a little code in here. I'm just going to quickly display the user's information here. So console.WriteLine, give it a little bit of a title here. So we're going to clear the screen. No, we'll just say user info. And then we'll actually display it on the next line, console.WriteLine. Let's say name. We're going to add on the name, of course. And then we'll do the age. That should be username. Come back to that in a second. Oops. And then we'll do user age. Okay. So if I run my program right now, we should see no difference. We can get rid of the pi here. We don't need pi. And we run our program. all we get is name Patty, which is from up here. We created our template, we created our stamp called display user info, but we're not actually using it anywhere. We've just created kind of like the design for it. So what happens is whenever we want to use this, we're going to call it by its name. So let's say we want to use it up here. So instead of this, we are going to, where's my end key? We are going to say display user info. Now it's a subprogram. So subprograms always end with brackets. Now, those are brackets. We have to put something in these brackets. When we created this signature line, what we did is we set up a contract. And that contract says, whenever I want to use this subprogram, I have to supply it with a string and an integer in that order. The subprogram doesn't care what the values of those are, but it does care that they are strings and integers. Our logic cares what values they are, but the subprogram doesn't know or care. It just does its job. It says, I'm going to take this variable and shove it here. I'm going to take this variable and shove it here. Whatever values are currently in those variables. But we just define those variables. Where do they get their values from? They get their values when we call the subprogram. So here I have to supply a string and an integer in that order. So let's say Betty, and Betty is 23 years old. So we look at this, it's saying, all right, username, so it's going to take this value of Betty and it's going to store it in username. It's going to take this value 23 and it's going to store it in user age. Now I can call this multiple times and I'm going to do so, but we're going to change the values. Oops, we are going to say, let's see, what's another name? Jill. Jill, and Jill, how old is Jill? Jill is 14. Okay, so we got Betty and Jill. Now if we run our program, oh my goodness, if we run our program, we get an error. Object reference is required. Oh, we got that static problem again. Well, what's the issue? We defined something outside of main and we tried to use it inside of main. So our subprogram, we defined it outside of main, but we didn't make it static. So we got to say static right here. Public static void display user info. Now we can use it inside of this static area. So now if we run it, we get all the information we expect. So we got user info, name Betty, age 23. User info, name Jill, age 14. So we got all the information we expected to. And we did it in 2 separate calls. So what happened in terms of functionality, Betty was copied into username, 23 was copied into user age. It came inside of here, it displayed all 3 output commands, it exited, deleted those 2 variables, came back up to the main program, and then did it all again. It says, go to display your info, create a variable called username, and copy Jill in it. Create a variable called user age, and copy 14 in it. Display the data, come back and delete those variables, and then continue with the program. Well, there's nothing else in the program. So I have literal values in here. I could just as easily use variables. Let's say I put age here. Now if we run this, we should get the exact same results, except Jill will be 17 instead of 14. And she is. Now this is where a layer of complication comes in. So let's look at how this actually works. When we get down to this final display user info line, what happens is it comes down here, it jumps down here, it says create a variable called username. Copy Jill in that variable. It's just a copy of the data. And then it says create a variable called user age. Now this is its own variable. It has nothing to do with any other variables in the program. Create a variable called user age. Now copy, oh wait, that's a variable. Copy 17, the value that's stored in the variable, not the actual variable itself, the value that's stored in the variable into the new variable. So that means 17 is going to be in there. If I change user age, down here, let's say user age is equal to 5, and then I display age up here, what you're going to find, oh my goodness, what did I break? Why did it do that? Try again. There we go. I don't know why that happened. Okay. So if you look at this, we went inside of here, we copied 17 into user age. We displayed all that information, so 17 came out for Jill. And then we changed the value of user age to 5. We came back, and then we displayed the value of age. So just to show you that these are actually two separate variables, age and user age, I changed user age here, but age maintained its original 17. What that should tell you is that they are not linked in any way, shape, or form at all. When we first called this subprogram, it just took the value that was stored in age and copied it into user age. So it's its own variable, and as soon as this subprogram is done, both username and user age got tossed in the trash. They don't exist anymore. We don't need them. So that is a procedure. It just does work. Didn't calculate anything, didn't return any values or anything like that. Now, the only difference between it and a function is that a function also gives data back. So let's create something simple. Let's create something that calculates the area of a rectangle. So let's say public, can't forget the static, and now whenever we want to create a function, we have to specify what kind of data is coming back. So for example, we did console.readLine, that always gives back a string, so that would have had string right there. We're going to calculate the area of a rectangle. I don't know what units we're going to be working in, so let's just err on the side of caution, and we'll use double for now. Public static double, and we want to calculate the area of a rectangle. So let's say calc rec area. Not only is it using mixed case, but it also has a very clear name, calculate rectangle area. Well, we all know the dimensions of a rectangle, or what defines the dimensions of a rectangle. How do we calculate the area? Well, the area of a rectangle is just length times width. So I need that data. Parameters purposes, the only purpose of a parameter is for data that is required to do the job inside the subprogram. So this subprogram could not have executed properly without that data, username and user age. So down in here, we are going to say double length and double width. Perfect. Now we're just going to open and close our brackets, and we're just going to simply calculate everything. I'm going to create a variable in here for the actual area, double area, and I'm going to set that equal to length times width. Second. Sorry about that, had somebody at the door. So basically what we're looking at right now is we've calculated the area. Great, now what? Well, remember, every subprogram does a single job. The job of this subprogram up here, display user info, is only to display the user info. It does nothing else. Wow. Okay. I don't know what we're doing with that. Inconvenient timing. That's okay. Anyways, so we're looking at this, and it does one job. Calc rec area does one job. It just calculates the area. It does not display the area. That's not its job. Its job is simply to calculate it. Something else will display it. So what is that something else? Well, probably the rest of the program. So how are we gonna do that? Well, we have to return the value first of all. Every function requires a return statement, at least one. Sometimes you can have more than one if you code it properly, if it's inside of if statements or something like that. But right now, we're just going to return, and then we have to specify what exactly we're going to return. The key here is that whatever we return has to match. School's very active today. Sorry about that. So what I was saying is we need to return the same data type that we specified in the signature line, which is a double. Well, area is a double, so we're safe. So we're going to return the area. Where does it get returned to? It doesn't get returned to the user. It's not displayed. It gets returned to the program. So wherever we called it in our program. So let's go back up and get rid of all this testing data that we were using. And now we're going to call our function. We're going to say calc rec area. We can specify anything we want for a length and width. I don't know, 3.2 and 4.7. We could also use variables there as well, or we could even get the data from the user, as long as it's a double on both sides. That's all that matters because we asked for 2 doubles. You'll notice that we don't put the area variable in there because it's not incoming data. It's data that's actually calculated within, which is why I created it inside. And just like these temporary variables, these local variables, as soon as the subprogram is done, area will get deleted as well, which is why we need to store it. Right now, calling the subprogram will actually do the work. It'll go in, it'll calculate the area, and then it'll return it back. But we're not storing it right now, which means we just wasted our time because it got thrown away. So we need a variable to store the result in. So I'm going to create a variable. I'm going to call it double rec area. Great. And down here, I'm going to assign it equal to that. Rec area is assigned calc rec area. And now I can display it on the screen. Let's see. Console.writeLine. Rec1. Just doing it like this so I can actually try it more than once. Rec area. And that's it. Now I suppose I could put some units in there, but I didn't give units originally, so we're just going to leave that. Now I'm going to copy and paste these 2 lines so we can do it again. I'm even actually overwriting the, if you look, I'm actually overwriting, I'm going to overwrite that variable, the rec area variable. So the data is going to be lost from the first call, but that's okay. We're just testing right now anyway. So we're going to take that rec area and instead we're going to put, let's say 2 and 5, which should give us a nice value of 10. And this one's going to be rec2. All right. So in theory, we should have a function that calculates the area of a rectangle. We're going to call it 2 times, and each time we're going to give it different data, and we're going to display that data. Let's give it a go. So the first time we did it, we got 3.2 times 4.7 and 15.04. That looks correct. And then rec2, we got a result of 10, exactly what we expected. So it comes in, it copies the data from the parameters into the local variables, copies, very important. And then it does the work, returns the result back, we store it, and then we display it. Now, sometimes you may not need to store it. Most times you do. I would say 90% of the time you should be storing it so you're not recalculating things unnecessarily. But let's say, for example, you didn't actually need to store it. You could, in theory, do all of this on one line. You could just have done it right there. So you're actually outputting the result of the function, in theory. But that, we try not to do that. Your output statements should be clean. They should not have any processing on them. You should be processing results data. You should not be doing calculations during your output statements unless you absolutely have to do that. So that's subprograms. We got procedures and we got functions and a few interruptions during the video, but we made it through to the end.